Local variables. Instead of wiring from one point to another way to get around this is to add a local variable. And this is an example of a local variable right here. If I want to add one, basically you just right click, go to structures, and down at the bottom here is local variable. I put it on the page, and that local variable will link to other variables on the block diagram. And notice that this one is ready to accept data, but you can right click on it and say change to read, and now the arrow is pointing on the right, ready to receive data. And if you want to select the variable, you just click on this and a drop down appears and allows you to select one of the variables that's used in your program. So for example, if you have the variable PV for process variable, it's now outputting to here. And I could right click on this terminal and say create indicator, and now I'm on my indicator. I would see the value of the process variable in my program. A bundle is a special type of function that allows you to combine different data types, for example a Boolean, an integer, a real data type, and it bundles it into one bigger cable. As you might think of this as a cable that might accept telephone signals, cable signals, internet signals, and bundles them all together. So you can see in this diagram here, I have a bundle, and I can add more to the bundle, but I currently have two wires coming into the bundle. They're the inputs, and these are the outputs. If you want to find where to get that bundle, what you can do is you right click on the block diagram, go to search, and in search, type in bundle. This is very useful for any other functions that you can't easily find, and it goes to bundle, and you can see it's under programming, cluster class, and variants, and there's the bundle. So that's where you would put it on your page. Now the reason I'm using the bundle here is because I have a display, a meter that I want to use, and that meter is going to have two gauges on it. So on my front panel, I have this gauge that I can display, and it actually has two needles. So if you right click on it and go to add needle, this is where you could add another one, but I'm going to go to the display format, and I'm going to go to the display format, and you'll notice here that there are three values that I can edit: numeric, display 0, and display 1. This represents the different needles on the display. Okay, and I want everything to always be in floating point, 2 digits, and digits of precision. So if I go to digital 0, floating point, 2 digits, digits of precision, and turn off the hide trailing zeros, and then display 1. If I wanted a third needle, but I'm going to delete it eventually, you can see here in my my front panel, I have two needles, and I'm going to heat up my thermistor. And that's causing the yellow needle to go up, causing an overload. And what I have is my variable resistor that I can adjust. Let's say it's going to be 2.3 volts. That I have an overload as long as the yellow, which is the voltage from the thermistor, is higher than that blue needle. So that's why it's kind of useful to have two needles on the screen. Okay, and I can adjust this as my set point, and the yellow is my process variable from my thermistor. In line number 8, what I wanted to do is to convert the process variable voltage to a resistance so I can compare it with a lookup table. And to do that, I have to calculate the resistance, and resistance is equal to voltage divided by current. So the voltage, in my case, I measured the supply voltage to be 4.54, subtracted the process variable voltage, and that gives me the voltage across the thermistor. And then I have to calculate the current, and that's the process variable divided by the 10K resistor. And when you do that, basically this formula node is reading the process voltage from this local variable and outputting it as a resistance, so then I can compare it in the resistance chart. The next demo is on wire cleanup. Well, here's an example right here where you see the stop button. I can see that this is the output of the stop button. The stop is a control, but the wire seems to be coming from the bottom of that control. So what we have to do is to clean up the wire. And the way that you do that is you just right click on the wire and say clean up wire. And even that doesn't work sometimes, which it didn't in this case here. Let's try it again. Seems to be coming from the bottom. Click on that, do clean up wire, and now that's correct. So signals should be coming from the right when they're an output and coming in from the left when they're an input. Everything else seems to be okay. But if you ever run into that problem, you just right click on the wire and say clean up wire. Okay, and sometimes it doesn't give you what you want. So quite often what I'll do is click on the wire and then just use the arrow keys to move things around and make things look a little bit better. You want to have a clean diagram once you are finished. Another troubleshooting technique in LabVIEW is to use a probe. And the probe is done by clicking on the wire that you want to monitor as you're looking at the block diagram. So I right click and insert, down here, click on probe, and you get this window opening here. It's just telling you that the data type is a scalar, and it's connected to where it says number 6. And then if I want to look at the process variable, I click on that, click on probe, and now it's got the process variable. It doesn't show anything here because the program's not running. So I'll click on run, and now it's telling me that my value for the probe number 6, which is the set point, is 2.38, and I can adjust the set point by adjusting my variable resistor. And then the second one is a scalar, and I'm heating it up, my thermistor, and it's changing the voltage. Okay, and it also shows you date and time and probe values on the right. So very useful in troubleshooting. I can stop it by clicking the X and just closing. Actually, I don't know if that was on the page, so I'll just add it again. Yeah, the page, when I'm doing a screen capture, I'm not doing the whole page. So there's one of them. And here's the other one. I click on there, add a probe, it's number 9, and I can switch between those two values. Very useful. So close it off. This operation will close all the probes. Yes. The other thing that's in this program is something called a feedback node. And as I said before, I'm going to stop the program. I'm going to right click. And you might not know where that feedback node is, but it's actually found in programming structures. So let's just do that again right here. But as I said before, if you want to search for it, you can just type in, for example, feedback. And it tells you right here, feedback node. And it goes into the palette where it's stored and highlights it. So it's a quick way to find it. Now what the feedback node does is whenever you want to latch an output, in this case we want to latch the motor signal, we're taking the output, feeding it back into an input, which we call motor, and the initial value is 0. So when you run the program, the output will be initially 0. That's what the input is for. And whenever you want to add a new variable to an input or an output, you'd right click on the right hand side and add output, or right click on the left hand side and add input. You can do it at any time you want. If you want to add line numbers like I've done here, very useful in troubleshooting and describing a problem, you go to visible items and click on line numbers. You can also add a scroll bar at the bottom if the program becomes too wide. Okay, so very useful. Now in the program, just to note a few things, if you want to Boolean and two things together, use these two ampersands in series together. If you want to OR, you're going to use the two OR symbols. The other thing to be aware of is the formula node is case sensitive. So if you're using a variable, make sure that the variable that you have on the left hand side matches up with the variable that you're using in the program. In this case, I used motor lowercase, start and stop uppercase. You have to use the same thing. The other thing to note here is that when you're working with a formula node, it doesn't accept Boolean data type. So you have to convert a Boolean data type in green to an integer data type in blue, and you do that with something called Boolean to 0 or 1. And I think you find that in the Boolean palette. Let's have a look. So you go to Boolean, and it's question mark 0 to 1, and that's right here. So if you want to place it on the block diagram, that's how you do it. The second possibility is when you're outputting something. Well, it's outputting it as a numerical value, and I need to convert it. So I'm looking for not equal to 0. I believe that's under the comparison palette. And if you search here, this is it here, not equal to 0. So that's where you would find that. Here are some examples for the DAC assist. So for the DAC assist, where I'm reading the analog input, let's open this up. So it's a double click when the program is not running. Hopefully it's in the frame that I'm screen capturing. Okay, and most of it is here, so cancel to that. So what I'm seeing here is that I have the thermistor, and you can open up details to see that the thermistor is connected to analog input 0, potentiometer to analog input 1. And if you want to test it right here, you can run it, and it's showing me the voltage of each of those. So the potentiometer, I can see as I increase it, it's going up as I turn it clockwise. Once you're all done, you can say OK, which is on the right. I'd stop this first. You're not seeing it in the screen capture, but click OK, and it creates that analog input. The other thing to be aware of is we have this function right here. We'll just wait a second for the DAC assist to complete. Okay, and if you double click on these functions, that takes a little bit of time. It's just building that. So I'm going to move this up here a little bit. So if you, I think a window got closed there, so I just have to make some modifications. So as I said, you open up this function here, and you'll see that it's called configure convert from dynamic data type, and you have to make sure that you're selecting single scalar. That's very important. And which channel you want to read the data from. Do you want to read it from 1 or 0? And you can actually do it here, or you can add it to that configuration at some other time. I'm going to click OK to that. Here I have the front panel, and avoid using this run continuously. Use run. Okay, and my program is running, but I've got the variable set very high. So let me just show you a few things here. So I have my green push button, which is normally off, and when I press it, it goes on. My stop push button is pulled high, so when I press it, it gets grounded. The green one is pulled low. When I press it, it goes to +5. So my motor is turning on because my set point is higher than my thermistor temperature. I'm going to drop this a little bit. Okay, and then increase the temperature, goes up, turns off my overload, and even if I try to start it here, okay, the motor never comes on. I have to wait till the temperature comes down below my set point, which happens to be 2.29. My process variable, the thermistor, is 2.37. So I'm just waiting for it to come lower than that. And it's almost there. Okay. Now, as long as it's not flushing, the overload is gone away. I can press the start button and then the stop button. Start, stop. Everything works okay. Now let me show you a few other things. If you want to change the colors on these, you stop the program, you click on that icon, and we go to properties, and you can see I can make the on color green, and I made the off color red. Whereas if I go to the start button, go to properties, the on color is green, the off color is red. Same thing for the overload and the motor. And as I said, all of your variables should only be to 2 significant digits. So if I right click on that and go to display format, it should be set to floating point and 2 digits of precision, and turn off the hide trailing zeros. Here we only have a numerical value. So do that for all in your program. The only thing I noticed here is the thermistor resistance. We don't need to go down to 0.5 ohms. So let's just run it. You can see it's jumping around too much. So I don't need that many digits of precision. So I'm going to make a change. One of the things I can do for that resistance value so that you don't see it jumping up and down quite a bit on the last digit. It's not very important to have more than 3 digits. So let's switch to scientific notation, or sorry, SI notation. That was incorrect. And we only want to look at 3 digits that are significant. So set up the screen like this, and now when I run it, okay, I'm going to run this here, and you can see that now my resistance isn't jumping around a lot. It's just telling me 11.2K. And the nice thing about having that on the screen and this resistance chart on the screen, the yellow arrow is indicating the resistance. So as I heat up the thermistor, it's at 11.11K, which is about 23 degrees. Okay, and now it's 8.9K. Around 8K. So we went up to about 30 degrees. Okay, so you can see the resistance and convert it to temperature, and there are ways to actually convert it in the program as well. But this is an example of that. Now the other thing that you can do is on the gauge that I have here, if you want to change the scale, let's say I never get up to 3 volts, and maybe the highest I get to is 2.5. I can just double click on that and say 2.5. Okay, so that gives me a scale with a lower range, but a little bit greater precision. So when I heat this up, now it's kind of bouncy because our supply voltage might not be super great. One of the things that you could do is add a regulator, but everything seems to be working okay. And what I did for this chart here is that you can just copy a graphic from somewheres and then paste it by going up to Edit and paste it right into your document under Edit and paste it if I had something coming from there. Okay, and this box is probably a little bit too big, so I can change that. The other thing I wanted to show you is how you can group things. So if we want to group things, let's say I wanted to group together the set point and the process variable. Well, first of all, one of the things I can do, I'm going to make this a little bit smaller here. I don't need that much text. I think it was bigger before. I'm going to move this out of the way. And let's say I wanted to group these two things together. So I would group them together. This is called a marquee. So they're kind of together. Right click. Oops, sorry. It's up here. Okay, it's reorder. I think it's actually reorder and group. So I'm going to group those two together. So now you can see when I move it, it moves around together. The next thing I can do is put a box around it. So you do that by going to decorations. I'm going to use this box. And right now that covered everything underneath. So you have to change the layering. And you can do that here as well. So you select this, and then I believe it has to have a marquee around it, which it does right now. Select it and move to the back. And now it's together, but if I move this, it doesn't stay with that. So again, I can group this and come up here and say group. And now when you do that, they stay together. So that's very useful. Another thing you might want to do in LabVIEW is to change the text size. So I can text size, color, and so on. So this says thermistor resistance. I come up to here and I can change the size. Let's say I want it to be 18. Let's go a little bit bigger. Size 24, and you can see that text is much larger now. And if I want to change the color, I can come up to here as well, do color and make it red. And if I want it to be bold, I can do style and bold, and I can even center it. So that's where you do that. You come up to here. You can justify things again with these commands here. You know, align to the top, center, bottom, And this one is for grouping things together and centering objects on the page. So lots of possibilities.